Hi everybody, so we're going to talk about 5.3, the logarithmic function. If you haven't watched the 5.1 and 5.2 videos, you might want to watch those first. Here's a few just really important reminders. So in 5.2, we talked about the exponential function, f of x equals a to the x. We mentioned that that was a one-to-one function, so it passes the horizontal line test, which means that not only does it have an inverse, but its inverse is a function, and so that's really important to remember. Then we talked in 5.1 about a couple of properties of inverses. So if f inverse of x is the inverse of f of x, all x and y values are exchanged. So if you have like the point 3, 2 in one graph, it'll be the point 2, 3 in the inverse. So you just literally switch the x and y values. That also means that the domain and the range switch. So the domain of the original function becomes the range of the inverse, and then the range of the original function becomes the domain of the inverse. So all of those things are going to be really important. And then lastly, we talked about in 5.1 that if a function is one-to-one, then you should be able to compose the functions in either order and you will get x back. That's the whole point of an inverse, okay? So, just a few reminders. So talking about an exponential function, let's just take f of x equals 5 to the x, okay? What if we wanted to solve for the inverse? Because we just said it has an inverse. The inverse is a function, so what is it? So the way we solve for an inverse, first of all, f of x is the same as just y. So we could just rewrite that as y equals 5 to the x, and then we switch the x and the y values. Okay, so we get x equals 5 to the y. And then the goal here is to solve it for y. How do you do that? We need a different function, right? So if you think of like, take f of x equals x squared. The inverse, if you switch the x and the y and then you solve for y, we get plus or minus square root of x. Why do we get that? Because someone at some point said x squared needs an inverse, let's make it look like that symbol. That's why. No other reason. Someone had to come up with that, right? So same thing here. Someone at some point said the exponential function has an inverse. What is it? Well, we need to give it a name, okay? The way we define it is y equals the log base 5 of x. Everyone say that. Log base 5 of x. You can say that in your living room. So what's tricky about an exponential function is it depends on the base. So there's not just like one exponential function. It's 2 to the x, 5 to the x, 10 to the x, e to the x, right? So see, we had f of x equals 3/4 to the x. Well, we need an inverse of that. Well, I don't want to define like an entirely different inverse function just because it has a different base. So what I do is I just say it's the log base 3/4 of x, okay? Or f of x equals e to the x. So if you remember, e is about 2.718. It's just an irrational number like pi. So what is its inverse? The log base e of x, which we're actually going to give a special name. Okay, so what's important right now is that you see these two equations. They're equivalent equations. It's just this one's solved for x, this one is solved for y, but they actually mean the exact same thing. Okay, so that's important thing number one. So x equals a to the y if you solve that for y, is y equals the log base a of x. If you remember from 5.2, we said that a has to be greater than 0 and a cannot equal 1, so we have the same restrictions here, okay? So, if we have a function, the question is, what is its inverse? Okay, so let's take the function, we'll start with a simpler one, okay? What if we just had the function 2 times x? What's the inverse of multiplying by 2? Hopefully, you in your head, you went x divided by 2. So multiplying by 2 and dividing by 2 are inverses. They undo each other, right? So these would be inverse functions. If you have f of x equals x plus 5, well, what's the inverse of adding 5? Subtracting 5. So x plus 5 and x minus 5 would be inverses of each other. They undo each other. So what if you have like 8 to the x? What's the inverse? So by definition, the whole point of a log is that it is the inverse of an exponential function. So the inverse of 8 to the x is the log base 8 of x. So what if we had like the log base 1/2 of x? What would the inverse of that be? Well, inverses go both ways. Okay, so if the log is the inverse of an exponential, guess what? The exponential is the inverse of the log. So the log base 1/2 of x, its inverse would be 1/2 to the x power. Okay? So, you can pause it, take notes. So if you have your notes from 5.2, we listed out a whole bunch of properties of the graphs. And so you might want to pull those out and compare. So when we're doing the graphs, remember the exponential function, we actually had 2 options for the graph. It depended on if a was bigger than 1 or if a was less than 1. Sorry. So same thing here. If a is bigger than 1, your graph is going to have this general shape, and it's going to have a vertical asymptote of x equals 0. If a is less than 1, still positive, we don't let a be negative, but less than 1, so a fraction, like a half, 7/8, 0.2, right? Same vertical asymptote, but your graph is going to have this general shape. Okay? So, kind of comparing to what we did in 5.2. So, look at your notes from 5.2. Look at the domain and the range. So the domain of an exponential function was negative infinity to infinity. Well, that's the range of the log function. Look at the range of the exponential function from your notes. The range of an exponential function is from 0 to infinity. Well, that's the domain of the log. So the domain and the range of the exponential function, if you switch them, that's the domain and range of the log. We also wrote down that there was a horizontal asymptote for an exponential function of y equals 0. Well, if we exchange the x for y, that becomes x equals 0. So instead of a horizontal asymptote at y equals 0, we have a vertical asymptote of x equals 0, okay? Then we mentioned that the exponential function was 1 to 1. It passed the horizontal line test. So does this. It passes the horizontal line test. And then lastly, we listed a few points on your exponential function. If you switch the x and y value of each of those points, and I'm actually going to show you how I do this, then what you get is 1 over a negative 1, 1, 0, and a1. So the log will always go through those 3 points. Okay? So, when I am doing a graph of a log, this is how I do it. I say, so say we just want to graph f of x equals 4 to the x, or sorry, the log base 4 of x, okay? I actually like to make a table for 4 to the x. Why? Because that's the inverse. And I would rather deal with exponents than logs. So watch this. If I do, again, you're going to need to know your exponent rules, but you need those anyway. So 4 to the negative 1 is a fourth. 4 to the 0 is 1. 4 to the 1 is 4. So if you want to know points on the log, since they're inverses, I can literally just switch the x and y values of each point. So I get, if I switch those, I get a fourth negative 1. Switch those, I get 1, 0. Switch those, I get 4, 1. Then I know my shape. I'm not just going to randomly guess the shape. I'm going to learn what the shape is. So I know I have a vertical asymptote at x equals 0. If I plot my 3 points, so 1/4, negative 1, just get kind of close to a fourth. 1, 0, and 4, 1. Then I have the general shape of the graph, okay? So that's how I graph just a basic log function, is I like to start with the inverse, because it's exponential. That's easier for me to do math with, and then it's not hard to just switch the x and the y values, okay? So one more thing I want to mention about logs is we have 2 important ones that we use pretty often. So the common log, you actually have 2 log buttons just on your calculator, on the main calculator. Any scientific calculator has these 2 buttons. One of them just says log, log. Well, what's the base? 10. If the base is not written, you will always assume it is 10. We just use it so often because our whole number system is based in tens that we just get lazy and we quit writing the 10, okay? So if there's no base, it is a 10. The other one is the natural log. We actually probably use this one more, and we'll talk about why later, but this is ln. So you have a button on your calculator that says ln. It's right under the log button. That is the log base e, where e, you should memorize this number. It's about 2.718. If you have time at some point, you should just Google the number e. It's a pretty awesome number, actually. So anyway, those two logarithms you're going to see very, very often. You need to know what the bases of those are. So if there's no base written, it's a 10. If it's ln, or natural log, the base is e every single time. Okay? I'm going to do one more video on transformations, on how to graph a log with transformations. So if you think that can help, watch that one too.